Good morning. In this video, I'm going to show you some example problems from 4.6. There's about 1, 2, 3, 4, 5 that I'm going to show you on this video. So let's go ahead and get started. 4.6 involves the imaginary number I. So for this, I put this up here. I squared is equal to -1, and I is equal to square root of -1. I'm going to just go over a couple examples. So for example, x squared equals 2x squared plus 4. This is let's say we wanted to solve for x. What would you want to do would be move all the x's over to one side. So I'm going to subtract 2x squared from both sides of the equal sign. X squared minus 2x squared is -1x squared, or -x squared, equals 2x squared and -2x squared. Add to a 0. 4 drops down. We just have 4. To solve for x, what I want to do is divide by -1 to both sides, and I'm going to go up here, and we have x squared is equal to -4. Now to undo the square for the x, you take the square root, but we're taking the square root of a negative number, so we have to start thinking about using I, or the imaginary number for the square root of a negative number. X squared and the square root cancel each other out. You get x is equal to, and you could break up the square root of -4 into the square root of 4 times the square root of -1. Square root of 4, and I forgot the plus or minuses, don't forget that, plus or minus. This becomes plus or minus, square root of 4 is 2. I'm going to substitute the square root of -1 with I, and I get x is equal to positive 2i and negative 2i. So that's the first example problem. Next example problem. Let's say we wanted to add two complex numbers. -4 minus I is one complex number, and let's actually make it a subtraction problem. Let's subtract a complex number from another complex number. Let's subtract 4 plus 5i. Okay, two complex numbers being subtracted. When they're written in standard form, when complex numbers are written in standard form, the real part is in front, the imaginary part is in the back. What you do is you add the real parts or subtract the real parts together, and you add and subtract the imaginary parts together. Well, we have this negative sign. Let's go ahead and distribute a -1 into that quantity on the right hand side. And I'll take away the parentheses for the first one. We get -4 minus I minus 4 minus 5i. Okay? Now we basically combine like terms. -4 and -4 are like, so that makes a -8, and -i and -5i are like terms. That becomes -6i, and this is your answer to that problem. A complex number written in standard form with the real part in the front and the imaginary part in the back. Let's multiply some imaginary numbers. Let's do another example. Let's do 3i times the quantity 4 plus 2i. Okay, pure imaginary number 3i multiplied into a complex number with a real part and an imaginary part. We just basically distribute into the quantity 4 plus 2i. 3i times 4 is 12i. 3i times 2i is plus 6i squared. I squared is equal to -1, so we can substitute. That becomes 12i plus 6 times -1. And 6 times -1 is -6. And to write this in standard form, let's put the real part, the ones without the i's in front, and the imaginary part in the back. -6 plus 12i. Okay, two more example problems. These ones are kind of more difficult, so let's go ahead. I can't write on that side, that's scratch paper. And we're going to do two more example problems. Let's go with example. Let's divide by a complex number. We're going to take 5 and divide it by the complex number 3 minus 2i. Okay? What you need to do is basically rationalize the denominator, get rid of all the imaginary numbers in the bottom. So the way we do that is to multiply by the complex conjugate. Two complex conjugates multiplied together always produce a real number, and that's what our goal is when we're rationalizing the denominator. So we're going to multiplied by the complex conjugate of 3 minus 2i, which is 3 plus 2i. And in order to make that legal, you have to multiply the numerator as well, because this fraction right here is essentially I'm multiplying by 1. So what this becomes is a distribution problem, one where you're just distributing one monomial into a binomial, and then another one where you're multiplying two binomials together. So let's go ahead and distribute 5 into the quantity 3 plus 2i. That becomes 15 plus 10i. And we're going to put that over, and then we're going to basically FOIL on the bottom. And we get 3 times 3 is 9. 3 times 2i is plus 6i. Negative 2i times 3 is negative 6i. That's what I'm looking for. I'm looking for those middle terms, the imaginary numbers, to disappear. And negative 2i times positive 2i is negative 4i squared. I squared is equal to negative 1, so I'm going to substitute in there. And I'm going to get, so this goes away, and I get 15 plus 10i over 9 minus 4 times negative 1. 9 minus 4 times negative 1, this becomes a positive 4, and we get 15 plus 10i over 9 plus 4, that is 13, and that's your final answer. You have a real number on the bottom, you've rationalized the denominator, you divided by a complex number, and now to really write this in standard form, you want to break apart this fraction. You separate the real part, so 15 over 13 plus 10i over 13, where you have the real part and the imaginary part separate. Okay. Last example problem, we're going to, it's real simple. Let's do something like this. Example. Let's do 2 minus I to the 5th power. Okay? Well, the thing about imaginary numbers, so let's just go make a little chart over here. I is equal to square root of negative 1. I squared is equal to negative 1. I cubed would be negative 1 times the square root of negative 1, so that's negative I, okay, because that's equal to negative 1 times the square root of negative 1, negative I. And then I to the 4th would be negative I times I, which would make it equal to positive 1, because negative 1 times the square root of negative 1 times the square root of negative 1 would make negative 1 times negative 1, 1. But basically what I'm trying to show you is that this circulates. So it's going to be, it goes I, negative 1, cubed, negative I to the 4th, 1. And then if I wanted to times I to the 5th, that would be just I again. Okay, and it just keeps going around and around. So 2 minus I to the 5th power, well, that's just 2 minus I. Okay? Alright.